Hello, CSE 190. I'm Nathan,
And I'm Mandy.
and this is our final project. So, in this particular program, our robot is going to start off in an unknown location in a known map, and will have to reach a goal while navigating around walls.
So this is actually an extension off of PA1, but this time we included an MVP pathfinding algorithm in order to reach this goal. However, there are a few differences from PA1. For instance, the room is based on a fixed size room instead of a circular world like in PA1. For example, if we try to go over to the right and we're at the edge of the map, instead of traversing back to the left side like in PA1, we'll just have the robot not be able to move any further. Also, the robot will either move in the intended direction or it will stay in place, as opposed to where in PA1, the robot either moves in an intended direction or moves in a completely different direction.
Alright, so the code is pretty similar to the original PA1 code with the obvious added addition of MDP, plus a couple extra subtle changes to make everything mesh together. And the configuration file is also different. So along with the original data about the temperatures and textures, we also contain positions of the walls and the goals and the various data that the MDP requires to run properly. And also, we should make a particular note of this threshold variable, which basically tells the robot when it is done, which means it's the minimum confidence that the robot has to have before it can say that it has reached the goal and end the simulation. So we're ready to run it.
Yeah, let's run the program now.
So now we'll run the program. There it goes. And there it is.
All right, so we made a little room layout in the config just to make it easier to see what's going on. It's not actually used in any of our code, but it's just nice to reference. So the robot's true starting position for this example is going to be 0, 4, as noted in this line. So we'll start at 0, 4. So initially the robot actually thinks that we start at 3, 2, which is interesting. But 3, 2 is right below the goal. So the instruction the robot will receive based on the MVP is to go north to reach the goal. But we're actually at 0, 4, so when we move north, nothing happens since this is a fixed room and there's a wall around the room. So the robot actually stays there. So during the next reading we get, we think we're at 0, 4, which is correct now. So MVP tells us to go south. So if that happens once correctly, but then during the next time, we think that the robot stays still instead of moving. So it doesn't go move down to 2, 4, but it still gets the same instruction, which is move south. So during the next iteration, we move south correctly, so we end up at 2, 4. From here on out, we just move west during each iteration, and we correctly assume that we're in the right spot. So the robot eventually has its belief to the goal, which is what we wanted to do.
Alright, so we also published 2 new things in this program. Scripts. One of them is the results of the MDP, which is in policy results. So if we just... There it is. It's very similar. And the second one is... What is it? Path results?
Path results, yes.
Path results. And there that is. So it's just the belief of the robot, the position belief at each step.
So obviously we can change around some things in the config file to alter the behavior and outcome of the robot. So we can obviously change the maps, make it hot in some places, cold in some other places, neutral in other places, texture maps, change around where it's smooth and rocky. Or rough. I don't know. Is R rocky or...
I think it's rough.
Rough? Okay. Smooth or rough. The room layout, it's more for references. The code, there's no code that actually uses room layout. We can also change where the walls are and where the pits are, so that'll make things more interesting. We could also change the threshold. So if, for example, like the room's not very complicated or is more complicated, we can change the threshold to account for that. If we had more time, I think what we would like to try to do is to make the robot work in a circular world as opposed to just a fixed room, like in PA1. Um, yeah,
That's about it.
that's pretty much our program. Thanks.
Yep. Thank you. That's all. Goodbye.